Welcome to the class, dear students. Today I am going to focus on how to form a differential equation. That means for the given solution, we have to correspondingly form a differential equation. So how to do that? In the last classes, in the last videos, in the last lectures, what we have done is we have we have got an equation. For that, how many what is the order, what is the degree of that particular differential equation we have done. Whereas what we do now is, for the given solution, what is the corresponding differential equation we will be finding out. For example, I have an equation of the type y is equal to ax is there, suppose. Now here y is the dependent variable, x is the independent variable, and a is called as the arbitrary constant. This a is the arbitrary constant. So another equation like this I will give you, and a is an arbitrary constant. For example, another one you have, suppose, let us say y is equal to ax plus b is there. Then here a comma b are the arbitrary constants. So how we have to frame an equation, a differential equation, for this particular solution of the differential equation. So now here we are able to see there is one arbitrary constant and there are two arbitrary constants. So what we do, if there is one arbitrary constant, then we will differentiate this one time and get an equation by eliminating this arbitrary constant. So our focus is on to eliminate this arbitrary constants which are involved in the function. Now here in this example, you have two arbitrary constants. So we need to differentiate two times to get the differential equation. So by that we can eliminate the arbitrary constants. So now how to do that? Let us now see how to do the steps to form the differential equations. Steps to form a differential equation. What we need to do first is just identify how many how many number of arbitrary constants are there. How many number of arbitrary constants. How many number of arbitrary constants are present in the equation or present in the function or in the solution, we can say. These are all the solutions. Now in this questions, in this formation, what we are doing is, for the solution we are finding out the equation. Okay. So first step is that, because the number of arbitrary constants we see. So if there are n number of arbitrary constants, n number of arbitrary constants, then we differentiate n times. If there are n arbitrary constants, then you have to differentiate n times. This is what the second step. So if there are two arbitrary constants, you have to differentiate 2 times. 3 arbitrary constants, differentiate 3 times, like that. Once after differentiating, our job is eliminate the arbitrary constants. Eliminate the arbitrary constants. To eliminate the arbitrary constants, we generally follow two methods. Those methods by given methods. So what are those methods? We just check out, and then I will explain you, and then we will get, once elimination is over, then we get the required differential equation. We get the required differential equation. That is what the formation of the differential equation. These are the methods. Now what are the methods I will tell you. First we will solve the equation by using the first method. Method 1 is method 1 to form the differential equation. By using the problem, by taking a problem, I'll explain you. Form the differential equation. Form the differential equation of the curves, the family of the curves y is equal to a times of sine of mx plus b. A times of sine of mx plus b. M is a parameter, a and b are the arbitrary constants. Okay, so form the differential equation. So what we do now here in this, first there are how many arbitrary constants? There are two arbitrary constants. Two arbitrary constants. So what are they? A and b. So how many times we have to do differentiation? So 2 times differentiation must be done. 2 times differentiation must be done. Okay, so for this, now how to solve this? So you call this equation as 1. Now differentiating 1 with respect to x. So differentiating equation 1 with respect to x. So when we differentiate equation 1 with respect to x, y derivative is what? Dy by dx is equal to a times of, now what is the derivative of sine? Sine derivative is cosine of mx plus b. Now we have to use the chain rule, right? Inside there is a function whose coefficient is m. So it is a into m times of cosine of mx plus b. Now again we have to differentiate because there is 2 times you need to differentiate, correct? So once again if you differentiate, what we get? It is cosine derivative is negative sign. So it is minus a sine of mx plus b. Again there is we have to use the chain rule, right? In the chain rule again x will be there, m will be there. So m into m will be m square. So now if you observe, this whole thing can also be written as minus m square times of a sine of mx plus b. Now what is the sine of mx plus b? Is nothing but your original value, original function y. So therefore what is the required differential equation? D square y by dx square is equal to minus m square y is the differential equation. Observe that there is no arbitrary constants here. We have eliminated the arbitrary constants by differentiating 2 times, and we got this. And in this equation you are not supposed to see any arbitrary constants. So this is what the first problem. I hope you could understand. Now let us now solve the next problem. Problem number 2. So let us take this problem as again. Suppose y is equal to, now I am going to do the another problem. Y is equal to 2 times of a cosine 3x plus 3 times of b sine 3x. Okay, so this is what the problem. So what you do, there are how many arbitrary constants? There are 2 arbitrary constants. There are 2 arbitrary constants. So we have to do the differentiation 2 times. 2 arbitrary constants. So differentiate 2 times. Differentiate 2 times. So what we do now here? Find dy by dx. So let us see now in the equation 1. Call it as equation 1. And now what is the derivative of cosine? cosine derivative is minus sign. So it is minus 2a sine 3x. Now again, by using the chain rule, it is into 3. And 3x derivative is 3. Now cosine derivative is what? Sine derivative is what? Cosine. So it is 3 times of b cosine of 3x again multiplied by 3 because it is the chain rule. Now that gives you what actually? 3 multiplied by 2 is minus 6a times of sine 3x plus 9b times of cosine 3x. Now once again we have to do the differentiation d square y by dx square, and that gives you, now sine derivative again becomes cosine. So what is this? Minus 6 multiplied by 3 times of a cosine 3x. Again, now this is 9 multiplied by 3 times of b. Cosine derivative is negative sign, right? Minus sine 3x. So that gives you what here? Minus 18a cosine 3x minus 27b sine 3x. Now in these two we can see negative is common, minus is common, and you can observe that there is 18 and 27, there is 9 is common. So minus 9 if I take out, then it becomes 2 times of a cosine 3x plus 3 times of b sine 3x. So now why we have taken 9 common? I wanted to write this original function y in this form. So for that, what is, when I get 2 here, I want to get 2 but I don't want 18. So what I do, here also I want to see 27. Here it is 27 but I want to say 3. So what I do, I will take 9 as a common. So now it is giving you minus 9 times of the original function y. So what it gives us now? It gives us, therefore, d square y by dx square is equal to minus 9y is the required equation, required differential equation. I hope you could understand now. When you do the differentiation 2 times, we have eliminated the arbitrary